On example 1, part A says to plot the points indicated in the table on the provided grid and then draw horizontal and vertical line segments to connect the adjacent points. So we have the point 0, 1, so that means do not go to the left or right, but go up 1. 0, 3, do not go left or right, go up 3. 6, 3, go right 6 and up 3. 6, 1, go right 6 and up 1. So we're going to connect the adjacent points with vertical and horizontal lines. So we have a rectangle to begin with. So part B says, what are the equations for the lines that bound this region? So you have to remember some of your Algebra 1 skills. Remember a vertical line will always be x equals whatever the x coordinate is for every point on that line, and that's for vertical. And horizontal will always be y equals, and it's whatever the y coordinate is for every single point on that line. So that's how you write horizontal line equations. So this vertical line, every single point, that's the y-axis, every point on that y-axis has an x of 0. So the equation of that line would be x equals 0. This vertical line, every single point on that line would have an x of 6. So that would be x equals 6 for that vertical line. This horizontal line, every single point on that line has a y of 3. This is 0, 3, and 6, 3. So the equation would be y equals 3. And this horizontal line, every single point has a y of 1. This is 0, 1, and 6, 1. So the equation would be y equals 1. Part C says to find the perimeter and the area of the bounded region. So remember, perimeter is just the distance around. We know the lengths of horizontal and vertical lines very easily by just counting the units. So this is 1, 2, 3, 4, 5, 6 units. This is 1, 2. So this would also be 6 and 2. So when we add up all of the different sides, we have 6 plus 2 is 8, plus 6 is 14, plus 2 is 16. So our perimeter is 16. We're not given the units, so I'll just say units. The area for a rectangle is length times width, so our area would be 6 times 2, which is 12, and those units would be squared for area, so squared units. Part D says draw and describe the geometric solid that is created by revolving the bounded region about the y-axis. Okay, so I'm going to redraw my rectangle since I labeled everything there. Going over 1, 2, 3, 4, 5, 6. And we've got to pay attention to what line we're revolving around. We're revolving around the y-axis in part D. So we got to imagine this revolving around the y-axis. So the first step in drawing that is to draw the reflection of that object across the y-axis. So I'm going to go over 1, 2, 3, 4, 5, 6, and I'm going to draw the reflection of that rectangle. So if you imagine this revolving around the y-axis, at the top you have a flat surface that is going to be circular as it's going around. So you have this circular top, and same thing's happening on the bottom, circular bottom. And so what we have created is a very short but wide cylinder. And so we've drawn it, and now we're going to describe it as a cylinder, but we can do better than just cylinder. To specifically describe it, we can tell its radius and we can tell its height. So the radius of this cylinder, remember this all the way across would be the diameter. The radius would be 1, 2, 3, 4, 5, 6 units. The height is right here, which is 2 units. I just drew this as the circular reminder at the top and bottom, but that's not part of the height. This is the height of the rectangle, which is the height of the cylinder, which is 2 units. It says, what is the shape of the solid's vertical cross sections? So if we cut a cylinder vertically, remember if you open that up, the ninja that cut the cylinder perpendicular to the base, we have a rectangle. and then the shape of the solid's horizontal cross-section means you're parallel to the base, so your cross-section is whatever your base figure is, which is a circle. So we have answered all of the questions on Part D. Part E says, what is the volume of the solid? Well, the solid is a cylinder, so we know the volume formula for a cylinder is its base area, which is a circle, times the height that's filling up that cylinder. So we know our radius is 6 and our height is 2. We're ready to give our answer in terms of pi. So this would be pi times our radius of 6 squared times the height of 2. 6 squared is 36 times 2 is 72. So our volume is 72 pi units cubed since it's volume. Now the next drawing, it says to draw and describe the geometric solid formed by revolving the bounded region about the x-axis. So that's the difference between D and F. We revolved it around the y, now we're going to revolve it around the x. So I'm going to go back and draw my original rectangle again. And now we're revolving around the x. So we've got the circular motion going around the x-axis. Now the first thing I notice is that this cylinder is not touching the line I'm revolving around. This one touched the y-axis, and that's what we were revolving around. So we made a solid cylinder. With this one, when we revolve around the x, I hope you can picture that we've got this center part that's going to have a void. We're going to have a hole in the center of our cylinder. So the first thing I'm going to do in drawing the solid is I'm going to draw the reflection across the x-axis. And again, just a picture that we have this curved bases on both ends. As we're revolving around, we've got this flat surface that's curved on the top and curved on the bottom. So we have, it's kind of like a toilet paper roll figure that's created because we have this cylindrical motion that's happening, but we've got this void in the center, which is also another cylinder. Okay, so when we describe the geometric solid formed, we're going to say it's a cylinder, but it's not a solid cylinder. It has a cylinder removed from the center. So if you remember finding our volumes of composite solids, we did this. We did a cylinder being removed from a larger cylinder. The cylinder that we're looking at as the big one, we can look at its radius. It goes from the x-axis to the farthest point this way, which is 1, 2, 3 units. The height is, remember, the distance between the two bases. So that's the length of our rectangle here, which is 6. The cylinder we're removing is going to have the same height. It's still going to have a height of 6, but its radius is only from the x-axis to this point, which is 1 unit. And I can add units to each one of those. Those are just linear dimensions. Okay, so the large cylinder has a radius of 3 and a height of 6. The small one has a radius of 1 and a height of 6. So then it asks us, what is the volume of the solid? So we're going to have to find the volume of the first cylinder at pi r squared h using the first radius, the height's the same for both, and subtract out the volume of the second one using our second radius squared, but the same height. So here we have pi times 3 squared times 6, and we're subtracting pi times 1 squared times 6. So we're going to get our answer in terms of pi. 3 squared is 9 times 6 is 54. So this is 54 pi. 1 squared is 1 times 6 is 6. So this is 6 pi. Since both of those have a pi, they're considered like terms, so we can subtract 54 minus 6 to get 48 pi units cubed, since we're talking about volume.